Hi, myself Gautam Kumar TM from Steve Venkateswara College of Engineering, Bangalore. Today I am going to be explaining about direct structures and file system molding. First, let us look into the contents about today's video. I am going to be explaining about two topics, that is direct structures and file system molding. And direct structures, I will be explaining five subtopics, that is single level directory, two level directory, three structured directory, archive graph directory, general graph directory, and file system molding. Now let us look into the overview. Data structure. A data structure is like a roadmap that allows us to navigate and organize our files systematically. Think of it as an hierarchical tree-like structure. When directories or a folder containing files or subdirectories, understanding this organization is critical for managing data efficiently and finding files effortlessly. File system molding. File system molding enables the integration of a storing device and network shares into the existing directory structure. When a file system is molded, it can be accessible as a part of a directory tree. Now let us move on to the directory structures. Of files are stored on a random access storing devices, including hard disk, optimal disk, solid state disk, that is memory bases. A storing device can be used in its entirety for a file system. It is also subdivided for finer grained control. Disk can be divided into portions. Each disk or portions can be divided into RAD protected against failures. Portions are also known as mini disks or slides. Entirety containing the file systems known as volumes. Each volume that contains a file system must also contain information about the file. This information keeps from the entirety in a device directory or a volume table of a content. This is a figure of a typical file system organization. There is two file systems, that is partition A, partition B, and partition C. Now let us move on to the next one. Dir- the directory can be overviewed as a symbolic table that translates file names into their directory entries. As a directory contains information about files, including attributes, location, and ownership. First, search for a file. A directory structure is searched for a particular file in the directory. Files having symbolic names and similar names may include a relation between files. Using this similarity, it will be easy to find all those names matching as particular patterns. Second, creating a file. New files are new files needed to be created and added to the directory. Deleting a file. When a file is no longer needed, they will be able to remove it from the directory. List a directory. It is able to list the file in the directory structure and contains the directory of entry of each file in the list. Renaming of a file. Because of the name that file respects its contents in its user. It is possible to change the name when the contents or use of file ch- charges. Renaming a file may also allow its portions within the data structures to be changed. Transversing the file system. User may wish to access file every directory and every file within the data structure. To prove the reliability and consultants and directories of a system, save in the regular intervals or the timeline. First, let us look into the single level directory. A simplest directory structure is a single level directory structure. All files are contained in the same directories, which is easy to support and understand. A single level directory has significant limitations. When the number of files increase or when the system has more than one user, as a direct structure is single and the file the uniqueness of a file name has to be maintained, which is difficult when there are multiple users. Every single user or a single level directory may find difficult to remember the names of all files as number of files increase. Next, we'll move on to the second level directory. The second level directory structure or each user has its own free directory structure UFD. The UFDs have the similar structures, but only this lists only the files for each user or single user. When a user refers to a particular file, only the owner of user file directory is searched. The different user may not have the files with the same name as a as long as all files name within the each unique file directories. To create a file from a user, the operating system sets only the user unique file directories to access whether the other file that name exists or not. To delete a file, the operating system conforms to the search of local user user file directories. Thus, it can not accidentally delete users another file other files that is having the same name as this. Next, we'll move on to the third structured directories. A tree is most commonly directory structure. A tree has a root directory. Every file in the system has unique path and name. A directory contains a set of files or subdirectories. A directory is simply another file, but it treats in a special way. All directories have same internal format. One bit for in each directory entirely difference the entirety of a file. As a subdirectory, the special system can be called the user to create or delete the directories. This is all about the third directory structured directory. Let's move on to the archaic graph directory. The commonly subdirectory should be shared. A shared directory or a file will exist in the file system in two or more places at once. The directory structures prohibits the sharing of files or directories. The algorithmic graph is a graph with no cycles. It allows the directories to share subdirectories and files. Next, let us move on to the fifth one, general graph directory. First, we have problem. If if there are cycles, we want to avoid searching the composite wise solution. There is no limitation for directory accessing in search. The problem is with cycles, the reference or the code may not be non-zero even when there is no longer possible to refer a directory or a file. A value of O or a file is in the referee count to be that there is no more reference to a file or directory and the file cannot be deleted. Solution: garbage collection scheme can be used to determine whether the last reference has been deleted or not. This is all about the direct structures. Now let us move on to the file system molding. A file must be opened before its user. A file system must be molded before it can be available to proceed on system. Molding point. A location within the file directory when the file system is to be achieved. The molding process. The operating system is given the name of a devices and molding point. The operating system verifies that the device containing a valuable file system does not to be asking the device or a drive to read the direct device directory and verifying that the directories as the expecting format. The operating system notes that it is directory structure that a file system is mounted at specific mounting point. To illustrate the file system modeling, consider files shown in the figure. Triangles represent the subtree of a directory, and there are of interests first. Where figure 1b, it shows an unmolded volume of resistance on device or disk. At this point, the only file on existing file can be acc- accessed. And the next figure shows the effective of molding the volume resistance. On disk over the user, if the volume is unmounted, the file system is restored and situation depletes in the first figure. This is the example or installation of the file system molding. Now let's come to the conclusion. Directory structure proves an hierarchical organization of file and folders. It allows easy navigation, effectively data storage, and logical grouping of file data systems. File system molding is the process of interacting the external storage devices or network sharing into the extinct directory structure. A molding point acts as a connecting point, allowing the axis to mold the file system as if they are part of an animating file. Molding is crucial from sharing data between devices, accessing renewable media, and integrated networks. This is all about today's video. Thank you.